So for example 1, it is asking you to identify whether it is growth or decay, and then you are going to graph. So we're going to do that part together. Okay, so you can use your equation to tell whether it's growth or decay, and then when it does come time to graph, we are going to have to make sure that we label the asymptote, okay? So that's something new that we haven't had to do yet, so that's why we're going to just make a little note to ourselves that we do have to include that. Alright, so for growth or decay, you're going to look at the base. So remember, you're going to look at the base and not the initial value. So your base here is 3/4. Okay, so if it's 3/4, is that growth or decay? Yes, so decay, and that is because 3/4, the absolute value of that, is in between 0 and 1. Okay, great. So now what we're going to do is we are going to use the table on our graphing calculator, and that's going to help us identify what we want to scale by, okay? Because we might not want to do a 10 by 10. We want to have a good looking graph here. And I already know one point on the graph. What do I know just by looking at my equation? Yeah, 10 is the what? 10 is the y-intercept, okay, because that's your initial value. So what we're going to do is we're going to put in the y equals 10, and then this would be times 3/4, and then we use this key here, which is to the power of x. Okay, and instead of graphing, the one thing we do, oops, I pushed the graph. We're going to use our table. Don't worry about my graph. Okay, so we're going to go to the table, and I'm going to start at 0. I'm going to go by ones. We're going to be playing around with our changing tables today. Okay, and then I'm just going to look and see what's happening. Okay, because normally I would want to do -2 to 2, but if I look here, -2, as I keep going down, what's happening to the y values? Yeah, they're getting a lot bigger. And then as I go here, as the numbers are increasing, I'm getting closer and closer to what? Yeah, I'm going to be getting closer and closer to 0 because that's my asymptote. Okay, so maybe I want to start at -2, which is 17.8. And then at -1, 13.3. And again, I'm using my table here. 0, 10. And then as I keep looking at these points, I don't necessarily have to do every single one. Right? I can see that these are really close together, so maybe I would even skip a few and go down to 5. So 1, 2, and then at 5 I'm at 2.4. Maybe I'd skip a couple more. Let's look at that. Yeah, at 8 I'm at 1.0 if I round that. 9 I'm at 0.75. 10 I'm at 0.56. Okay, so you don't necessarily have to graph every single point, but you do want to have enough that it's going to give you a good picture of the graph. So on the x's I went by, I'm going to go by ones. What should I go by on the y's? Yes, I'm counting. Yeah, so if I go by 2, that's going to get me up to 20. So yeah, I like that. 2, 4, 6, 8, 10, 12, 14, 16. Okay, so so now I'm ready to plot my points. Now, when I plot my points, I am going to put a tiny dot, okay, for each one, because I do kind of, well, this isn't too bad of a scale, but it's going to be easier for me to connect my dots if I do that. So at -2, again, on the x's I went by 1, so -2 up to 17. This is 18, so 17.8 would be very close to 18. At -1, I'm at 13.3, so 8, 10, 12, 13. At 0, I'm at 10. At 1, I'm at 7.5. At 2, I'm at 5.6, so 2, 4, 5.6. And then you can see these are very close together. That's why I can skip a few and say, okay, yeah, this is going to be 2.4. At 8, I'm at 1.0. Okay, at 10, I'm at 0.56, which is really, really close to that x-axis. So I know that you can like faintly see these. Again, I'm just using those small dots to help me curve. And sometimes I like to graph it like this, upside down, to connect my points. You can do what is going to give you the best graph. Just make sure that you have an arrow on this side going up, and then the arrow here is going to be going to the side. Okay, so this is decay because it is getting closer and closer to that asymptote, which we are going to label. So like I said, the asymptote can be hard to show up, so I like to use a highlighter, but you are going to label it. It is a line, so you have to have that y equals. So it's going to be y equals 0. All right, and then for B, we're going to do something very similar where you start with, is it growth or decay? So let's look at the value of B. What's my value for B here? Yep, so 1.05. And so this is going to be growth because 1.05 is greater than 1. All right, so again, before you start to graph, we need to make our table. We got to see what's going on with these values. Now, when you look at your, again, when you look at your equation, right away, what is a point that we know? Yeah, 0, 100. So I know that this is going to be larger. Okay, so I'm probably not going to want to start with -2. Okay, this was 10. That was 10 times smaller. Okay, so again, let's go to our graphing calculator. Let's use our y equals. Okay, so 100, 1.05 to the power of x. And then I'm going to go to my table. Okay, so at 0, I'm at 100, just like I thought. Let's look and see what's happening. Okay, so as this gets lower, the numbers are getting lower, but see, these aren't decreasing very quickly. So one thing you could do is you could do a different scale in your table set. So let's try that. Go to second, and then above your window button, it says TBL set, so table set. So let's start, we can start at 0, but let's make our increments go by 5s. And let's see what happens. Okay, so see how these are decreasing a lot quicker? Again, you can decide what you want to go by. If I have 10 units here, okay, if I go by 5s, I'm going to get out to what number? If I have 10 units and I'm going by 5s, what number am I going to get out to? 50. Okay, so again, I can start with -50. You can actually go to your table set. You want to start at -50 and then just go to your table. Okay, so this would be about 8.7. Again, you do not have to do every single one. So maybe I would do 50, negative 50, and then negative 30. The key is you just want to have a good graph. And so I can start rounding those. At negative 10, I'm at 61. At 0, I know I'm at 100. So at 10, I'm at 162. At 20, I'm at 265. 30, I'm at 432. 40, I'm at 704. Bless you. At 50, it says I'm at 1,146.7, so 147. Okay, now even though I put that on my chart, I don't necessarily have to graph up to that much. What do you guys think a good scale would be for the Y's? If I have 10 up, what do you think a good scale would be? And then, but how far would you get to with 50? You get to about 500, right? Yeah, let's try hundreds, because then I could get up to 1,000, right? So I could graph everything up to this point. So 100, 200, 300, 400, 5, 6, 700, 8, 900. Okay, and then here I'm going by the 5. So 5, 10, 15, 20, 25, 30, 35, 40. And again, a lot of times I'm labeling this for me so that I 5, 10, oops, sorry, 15, 20, 25, 30. This one's 30, 35, 40, 45. Okay, and again, I like to start here. So at 40, I'm going to be at 704. So again, I'm just putting a dot. It is going to be very, very close to 700. So because those are going by hundreds, I'm pretty much putting it on that line. At 30, I'm at 432. So 10, 20, 25, 30. At 432. Again, I'm putting a dot. And then 20, 265. Going to be a little bit closer to 300. At 10, I'm at 162. At 0, I'm at 100. Yay. At negative 10, I'm at 61. So that would be about halfway. And then as you start to get closer here, really, you're just getting closer and closer to what? Your x-axis, okay? So, again, it's just easier for me to curve it like this. And it's just going to follow along that line, okay? So it's going to follow right along that x-axis. It is a curve. And depending on what your scale was, like if you went further out here, okay, the deeper you're going to see that exponential function. And then don't forget your asymptote. Okay, so write your y equals 0 on there. Okay, and then I want you to highlight your important solution in your story problem. Okay, for example 2.